Welcome back to my channel. So we continue our series on PDE. Today we are looking at linear PDEs, and the first thing we will talk about is that if we have a PDE, so let L be an operator. L be an operator such that if L acts on U, that is our solution, we will get 0. So if L acts on our solution, we get 0. So let's label our equation as equation 1 or star. So in this case, for L to be a linear operator, it has to satisfy these two conditions. That is, one, when L acts on two functions, u plus v, it should be the same as lu plus lv. And then when it acts on a scalar, multiplied by any function, that is cu, we'll say it can be written as clu. But we can combine all these two functions into one. So combined, so that we will not be solving all the two of them. So we can use the combined version, and we can write that one as lau plus bv to be equal to alu plus blv. So if you're able to show that the left hand side is equal to the right hand side, then we can conclude that this particular L here is a linear operator. Alright, so without wasting my time, let's take an example and show how we can go about it. So an example, show that the PD ux plus xuy is equal to 0 is linear. So what we do is that we employ whatever we used in the combined version. So we know that L, so solution, L au plus bv, and that will be equal to, so we substitute that in place of this one. So the whole of this one is our u, so we substitute it here. And so when we substitute, what are we going to have? We're going to have, this is now our u. So everything that we see here, we substitute it in place of u here. So we have au plus bv multiplying x, as we have x down here, plus the same thing, x out, we have au plus bv, and then we have y down here. Now when we take the x inside, we have aux plus bvx, right, plus x out, we still have our auy plus bv, right. So this is what we have. Then we can expand whatever we have here. Then we have aux plus bvx plus ax uy plus bx vy. Alright, so we can group like terms so that we can be able to rewrite that in terms of alu plus blv. So what we have to do is that all the a's comes to one side, and then we'll have aux plus ax uy plus bvx plus bx vy. So in this our case, we can factorize a out, and then when I factorize a out, I have ux plus xuy, right, plus, then I factorize b out, I have b out, I have vx plus x vy, right. Now what does this one look like? It looks like the term u, the whole of this one is in terms of u, so we can write this one as alu plus, then we can also write this one in terms of v, right. So we can also say that this one is blv. Alright, so since we have been able to get to this conclusion, we will conclude that thus L is a linear operator. So thus L is a linear operator. L is a linear operator. The PDE is what? Linear. Hence, the PDE is linear. Alright. So I will leave one of the questions in, and then you can solve and then put your answer in the comment section. So the question is determine whether the PDE is the PDE UT plus U plus 2TX U is equal to T squared is linear. So if it is linear, let me know in the comment section. If it is non-linear, let me also know in the comment section. Alright, so that is that for linearity.